Good morning, students. I hope you all are well. These days we are doing vector spaces. Today we will discuss some important properties on vector space. But before this, let us revise. Axioms of a vector space, that means properties of vector space. There is an element 0 such that better to write this. Addition, scalar multiplication. These are the four properties of addition, and these are the four properties of scalar multiplication. As usual, I am not writing the closure property of addition as well as closure property of scalar multiplication. If we write, then we can say for all alpha beta belongs to P implies, and here for all A belongs to. Is a vector space over the field F. Okay, but remember here this plus sign, remember this operation, this is triple. Several times I have explained. this is a tuple. B, a non-empty set. This symbol, this is internal binary composition, V cross V to V, alpha comma beta, where image is alpha plus beta. Second, scalar multiplication, F cross V to V, this is A comma alpha, image is this one. So, whenever in your mind there is a word vector space, that means vector space is over a field. Generally we say V is a vector space, but it is incomplete statement. In your mind it must be completed. V is a vector space over the field F. If F is a set of real numbers, then we can say this is vector space over real numbers. That means a real vector space. If F is a set of complex numbers, then we say it is a complex vector space. If it is given a particular field, then we will mention it. Otherwise, if it is not given, we always consider a field as a set of real numbers. So here I say this is a vector space. It means V is a vector space over the set of real numbers. V is a vector space, that means two binary compositions are inbuilt. One is this, that is called addition. This is called scalar multiplication. You remember, with respect to this addition, V is an abelian group. So there are 5 properties, including this closure property. So 1, 2, 3, 4, 5. These 4 properties with closure property. So V with respect to this is an abelian group. Second one, scalar multiplication. It is not an ordinary multiplication. It is scalar multiplication. So one scalar means a number that is multiplied by vector. Again I am telling you, here vector does not mean the vector quantity that is given in vector algebra or in physics. Your vector may be a number, your vector may be a matrix, your vector may be a function, your vector may be a polynomial, etc. So here this is the brief introduction or brief revision about the vector space. Okay, so you have to remember all that. Again, one thing more. Remember, the elements of vector space are called vectors. So here this is a vector, this is a vector. So the operation between two vectors, it's just like addition of two matrices. It is this one. So here it is this particular symbol. Okay, it is repeated. You can see. This is ordinary plus, here symbol is not given, that means here this scalar multiplication, you can say. Similarly, this one, several times it is explained, this is the ordinary multiplication, this one is the unit element of the field. Here, alright, first property, prove that U and V are two members of particular vector space. Then if U plus V equals W plus V, then U equals to W. Means in ordinary algebra, generally we transpose or we can cancel it out. So it is given right side. So this is called right cancellation law. In the similar way, if I write in the left side, then that will be left cancellation law. So this is very important property. It looks like so simple because we have done in lower classes, but here we have to prove. Okay, so let us see. Can we write it? You just recall which property we have used. Remember, this 0 is not the ordinary one because this is a vector, so this must be a vector because this symbol is used. I write it here. We drop the symbol. This in the favor of ordinary sum. We drop the symbol this in the favor of ordinary sum. That means the plus sign. Again and again, I will not write. You have to understand what is going on. This plus is not this one. It is this symbol, but it is dropped because again and again we write. Then it is time consuming and irritating. So you think which plus is given between two scalars and which plus is given two vectors. So here U is a vector. So it is sum of two vectors, and this is the null vector. Zero vector. Zero element. See the name. And additive identity. Since V is a vector space, so there exists 0. That means 0 element. That means additive identity element. So this is that property. Okay, you must write here identity elements. These are right. This is the vector. Since V is the element of vector space, so its inverse exists. So this is the sum of the element and its inverse, and the answer is the identity element. So instead of this, here it is. This is U plus this is the associativity. Now U plus V, you people are given, that is W plus V. Given. Again I rewrite. Again I have applied. Then if you have some doubts to write 0 as 0 element or 0 scalar, then it is better to write this one. Okay, additive identity. It is up to you. You can write here where is the additive identity. Okay, and if any element is added to the identity element, then the answer is the element itself. Therefore, U equals to W. Nice put. I repeat, U plus V equals to W plus U. This implies U equals to W. This term is cancelled out. Answer is this. This is called right cancellation law. Several times it is asked in university examinations. So we begin with this one. U equals to U plus the identity element, because if any element is added to identity element, the answer is the element itself. Since these are the members of vector space, and we people are doing this property with respect to vector space. So this is a property of vector space. That means in set of vector space, cancellation law holds. You have done in abstract algebra, if G is a group, then the cancellation law holds here. In the similar way, so it is like this. Then this is the additive identity. So instead of additive identity, we can write the element and its inverse. So this is the addition of the element and its inverse. The answer is the identity element. That is the property, inverse exists. Then we have applied the associative law. You can say alpha plus beta plus gamma is alpha plus beta plus gamma. So it is that type of rule. U plus V equals to W plus V. This is given to us. So this is used here. Again the associative law is used. Then V plus minus V, that is the identity element, and identity element plus the element, whatever it is, then the answer is the element itself. So it is U equals W. Similar way you can prove the left cancellation law. Okay. We come to the next property. Before this one, write the alternative method. You see. Alternative method. Given that since V belongs to V, therefore minus V belongs to V exists. This is the element of vector space, so its inverse exists. Can see this? Okay. Which rule? Associativity. identity element. Identity exists. When you do the question in the examination, you must write the proper reason. Why people are writing like this? So it is this one. Then this is the identity element. So identity element is added to any element. The answer is the element itself. It is U equals to W. So this is the alternative way. You can begin with the given, then you can write this particular solution. Okay. Number 2. Prove that now remember, I told you these two look exactly the same, but it is not. This is the scalar. This is a vector. That means here it is scalar multiplication. The symbol between this one and this one is this symbol, but this symbol is dropped. You have to understand. This is a number. Ordinary 0. This is scalar multiplication. So the final answer is a vector. Therefore, is a vector. This is a vector quantity. Left hand side is a vector, so 100% the right hand side must be a vector. So this is a vector quantity and this is a vector quantity, so it is this one. This is additive identity. Okay. See, previously I wrote like this, but you remember what is going on. It must be clear in your mind. This is a vector quantity, here this is a scalar, this is a vector, so this is a scalar multiplication. Scalar multiplication, the final answer will be a vector, so left hand side must be equal to the right hand side must be a vector, so it is not the ordinary 0, this is a 0 vector or null vector, that means the additive identity. To avoid the confusion, I put the bar over it, so you can make a difference between this one and this one. This is the ordinary 0, this is not the ordinary 0, this is the additive identity. This is a vector quantity. So we want to prove this one. So first, whatever you have to prove, just analyze what is given to us. So, right here. Listen, this is a vector quantity, this is a vector quantity, this is a scalar, so it is scalar multiplication. I am using this property. If you remember, this is I am using this. This property we prefer is using here instead. What is A? A is scalar. B, this is also scalar. A is scalar, B is scalar, this is a vector quantity. So I am writing this. Then 0 plus 0 is 0, so it is this one. What this implies? Which property is used? This is a vector quantity. So this is alpha plus this equals to alpha means this. So here it is. Then it is this part is cancelled out. This is a commutative, or this property you can see whatever it is, and here it is right cancellation law. This part and this part from first question. That's why the right cancellation law was taught first. So we can use here. Again I repeat, use the distributive law. This is the distributive law. Two scalars, the sum is this. Now this is the vector quantity. This vector quantity, the identity is added, the vector quantity will be the same. Here it is. You can write this way also, commutative, or this is the property of identity element. Then we have applied the right cancellation law and the answer is obtained. Okay, so this is also important. Number 3. Remember, it looks so simple, but we have to prove. This type of situation we have done several times in previous classes. -1, this is a number. -1, I am saying. This is multiplied by this. So let us see. This can be written like this. V is nothing, it is 1 into V. You can write the property in C. 1 into alpha equals to 6. Write the proper reason why people are writing. This element is as such. But instead of this, I have written because it is that. Then is which property? Distributive law. This is used here. Now this is a number, this is also a number. So the answer is C. 0. Just proved. एग्जाम में नहीं लिखना है, जस्ट प्रूव्ड. राइट द प्रॉपर रीजन. Therefore, what will happen? This is a vector quantity. This is also a vector quantity. This plus this is the identity. So by definition, this implies minus 1 V is the inverse of V, which is denoted by this symbol. If you remember, axioms of a vector space, there is an element minus V belongs to the set of vector space such that V plus of minus V is the identity element. So this is the definition. So here if we find this type of situation, then this is the inverse of, which is denoted by this one, which is the, this is the inverse of V, which is denoted by this particular symbol, that is minus 1. That means this is the inverse and it is denoted by minus V. So this is equal to this one. So these are 3 important theorems or important properties generally asked in the university examination. So you have to think how to prove. It is not simply or ordinary algebra. You have to write the proper reason. Again and again you have to write. It looks so simple, but it is not. In every step you have to argue. You have to write the particular reason behind it. So it depends on the practice and practice and practice. Thank you. Thank you very much.